Hi, let's take a look at some homework problems from section 1.4. I've included mostly problems from my math lab, but these are very similar to the problems that you will see in the textbook. And I really do recommend that you work some additional problems from the textbook. You can check the odd answers in the back of the book, just because there are very few in my math lab that cover the topics that you're required to know, so it would be helpful if you can get some additional practice. So this first problem is to find the equation of the line shown in the two views, give the equation in slope-intercept form. Really one of the problems that we've talked about before, but it's just giving you the information in a slightly different manner. It's giving you the graph, but it does tell you the ordered pairs that lie on the graph. So this is nothing different than writing the equation of the line through the points 2, 2, and 4, negative 4. So to begin, the first thing that we need to find to write the equation of a line is the slope. This formula hopefully is embedded in your brain right now. y2 minus y sub 1 over x2 minus x sub 1. And I think again it's helpful if you can label the points x sub 1, y sub 1, and x sub 2, y sub 2. So plugging in, we have negative 4 minus 2 over 4 minus 2, which reduces to negative 6 over 2, or negative 3. So now that we know the slope, we can plug then into the point slope form of the line with one of our points and the slope. I suggest that you use this 2, 2 just because it doesn't have any negative values, but as you know, either of the points would produce the same equation. So we'd have y minus 2, which is equal to negative 3 times x minus 2. Now we just need to clean this up, distribute on the right, be careful with signs, so y minus 2 equals negative 3x plus 6. Add 2 to both sides to get y is equal to negative 3x plus 8. So this is the equation in slope-intercept form. We can check that on the calculator. To check on the calculator, you would input y equals negative 3x plus 8 into your equation editor. That is, press your y equals key. Enter negative 3x plus 8. Remember to use the negative sign from the bottom row. Then graph. And once you graph and press trace, do you remember how I've shown you you can enter an x value? So if you enter 2 and press enter, it takes you to the point that corresponds to that value of x. And notice that the 2, 2 is exactly what we were given in the information. If we press 4 and enter, it shows us that 4, negative 4 is on the graph, which confirms the points that were given in the problem. Another way is you could press second and graph to get to the table and see that both the 2, 2 and the 4, negative 4 are on the graph. Another problem that I've selected to work is number 3 from your My Math Lab homework. It is to find the distance between the points 14, 25 and 13, negative 22, and to find the midpoint of the line segment joining those 2 points. These are formulas that I alluded to at the very end of the lecture video on this material, but not something that I actually went through and worked a problem, but I think it's valuable for you to see this because it may have been a while. So for you to use the distance formula, recall that the distance formula is a square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. Remember, this derives from the Pythagorean theorem, a squared plus b squared is equal to c squared, and hence the a squared plus b squared in it. Then I just plug in my x1 minus x2, 14 minus 13 squared, plus then my y1 minus y2. Be careful with the double negative. When we simplify inside the parentheses first, we would get the square root of 1 squared plus 47 squared. Now, squaring those constant terms, we get 1, and then 47 squared is 2209. So then we combine inside parentheses first, or inside the square root symbol, to get the square root of 2210. Now to find the midpoint, remember that is just the average of the x and y values. And so we add those values and divide by 2. So x1 plus x2 is 14 plus 13 over 2. y1 plus y2 is 25 plus negative 22 over 2. So combining those gives us 27 halves, and 25 minus 22 is 3 halves. So that would be the midpoint of the line segment that joins those 2 points. Now, number 6 from the MyMathLab homework deals with incidents of farm pollution. It says in 1979, the number of farm pollution incidents reported in a certain country was 1,500. This number increased roughly at a rate of 260 per year after 1979. Let y represent the number of farm pollution incidents during the year x, and let x equal 0 correspond to the year 1979, x equals 1 to 1980, and so on. We've got to get the equation of the line that models the information and then estimate the number of incidents in 1983. So what I would suggest is that you actually get a feel for some ordered pairs that this is representing. So we know that the initial value, when x is 0, there were 1,500. Then we know that it increased at a rate of 260 per year. So that means in the next year it was 1,760, right? I just added 260 to that. I could continue if I add 260 to 1760. I get 2020, and I can continue in that pattern. But to get the equation, I need to know the slope and the y-intercept. And actually, this is a problem that was given that information to us directly. Do you recall that we talked about the initial value is the value of b? The slope is how it's changing. It says it's changing 260 per year. So 260 is an increase in incidence divided by 1, which is really an increase in year. So our equation is y is equal to 260x plus 1,500. Now, if you don't like that, you can go through and plug into the slope formula and find the slope between those 2 points, which you would find would be 260. Then you could use the point slope form if you needed, and plug in a point, and you would still find that you would have the equation that we just talked about. Okay, so that's going to give us that. Now, how can we find the number of incidents in 1983? Well, to do that, we have to understand what is the value of x there. X represents the number of years after 1979, so we can't just plug in 1983. We've got to subtract off that base year, so that gives us x equals 4. So to find how much we had in 1983, we're going to plug in the value of 4 to get 260 times 4 plus 1,500. And you may have to use your calculator to find out that value, and you would get that y is equal to 2,540 incidents. The next problem is giving us the average number of home runs per game, where x equals 0 is our base year of 1992, and so on. The x-axis represents the number of years since 1992, and the y-axis represents the average number of home runs per game. And we have to answer the questions. Now, do you notice that whenever you plot these points, and that was already given to us in this problem, that it's not a straight line, but the data points show that those points do kind of cluster around a linear equation. So that would suggest that a linear model is appropriate to describe the average number of home runs. You can do this in one of two ways. You can continue trying to find the best line by hand, or you can use your calculator to get the regression equation. This particular problem wants us to do more of the first method that I just described. It says to use 2 particular ordered pairs to choose the equation of the line. You're not always going to be asked to do that. Some problems say use these specific points. If it gives you specific points, then use those and do it by hand. If it says to find the regression equation, you've got to plug the points into the calculator. But by hand, we would have to find the slope. So y2 minus y1 over x2 minus x1. So 1.35 minus 1.24 is at 0.11 over 2. So our slope is what is that, 0.55? Just confirming on my calculator for a minute. Yep. Okay, so now we know the slope. More importantly, what else do we know? Anybody see? Yeah, we know this point here, which is a critical point, right? It is the y-intercept point. And so what we know is that m is 0.055 and b is 1.24. So when x is given, you know a lot of information about the line. So our equation is y is equal to 0.055x plus 1.24. Now, how else might you do that? You could have used the point slope form, and you could have plugged in a point. Doesn't really matter which one of those points we could plug in, and you would still get the same equation. This next problem, the data in the chart shows the cost of tuition at a state university. Fit a regression line, so this is our key that tells us we're going to involve the calculator, where x is the number of years after 1997. Then find the coefficient of correlation, which is really not something that you have to be able to do in this class. If there's a problem in my math lab that requires you to do it, just understand that the coefficient of correlation is a value of r that is displayed whenever you do the linear regression. If you have problems finding that, if your calculator is not displaying those, please contact me and I'll show you how to do that. Finally, use the regression line to predict the cost of tuition in the years 2004, 2007, and 2010. So where you have to start is you have to begin by entering these values into the calculator. I've already done some of these for you because I was having problems with this recording and it wouldn't allow me to do all of this. But what you would do, if you recall, you press Stat key and then choose option 1 is to edit. And if you have anything in your list, you can go up to the heading and press clear and enter, and that will erase the whole column. But then you want to enter your x values first, and then arrow to the right, and then enter your y values. So I've got all of those listed into the calculator. Once I do that, then I go back to the Stat menu, and I go over to Calculate and choose number 4. And then I would see linear regression appear, and then I'm going to press Enter. And when I press Enter, it gives me this information. Now when you press Enter, it's understanding that your X values are in L1 and your Y values are in L2. If you've done something to mess up that list and you don't have the L1 and the L2 columns in your calculator, you need to contact me because we need to get those back in there. You can enter other columns for it to compute the equation for, but I think it's just easier if you get them in L1 and L2. So this is telling me then that the slope of the line is 587. The value of b, which is the y-intercept, would be 9,810 if we round up. That correlation coefficient is 0.99, which is a very, very strong linear correlation. So that would be the value you would report if you needed to in this problem. So our equation is, we just plug in for a and b, which is 587x plus 9810. Now we're going to use that equation to predict the cost of tuition in the year 2004, 2007, and 2010. I'm just going to do it in the year 2007. So to do that, I've got to find out what x is, right? X is the number of years after 1997. So subtracting that base year off, we find that x is 10. Then replace our x value in the equation with 10 and simplify to get 15,680. So this is saying that if this trend continues, the cost of tuition at a state university would be $15,680 in the year 2007. Now, another problem that I want to show you, this is from your book, from section 1.4, and I honestly don't remember the page number right off the top of my head here. But this is to review parallel and perpendicular lines. Instead of just giving you two equations to say are these parallel or perpendicular, it's asking you to use some ordered pairs that are in the table. And you may not have seen it displayed like this, but if you enter two equations in the calculator and then go to table, you're going to see two columns filled in. But what that means, if you just look at the first two, those are ordered pairs that lie on that first graph. So like 0, -3, and 1, 1 lie on the first graph of y1. On the graph of y2, we have 0, 4. You always have to begin with an x value, and then the y value is in the corresponding column. And let's do one with whole numbers, 4, 3. Now remember what determines if they're parallel or perpendicular. Yeah, slope. We know that parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals. So if we find the slope between these two pairs of points, then we can determine if we have parallel or perpendicular lines. So we would have to do y2 minus y1, 1 minus -3, over x2 minus x1, which is 1 minus 0. So that's 1 plus 3, or 4 over 1, which is 4. For the second equation, the slope is 3 minus 4 over 4 minus 0, which is -1 over 4. Well, 4 and -1/4 are not the same, but are they negative reciprocals? Yes, because 4 is 4 over 1. Negative reciprocals are numbers whose signs are different and whose fractions are flipped. So that means that these two lines, that is y1 and y2, are perpendicular. So y1 is perpendicular to y2. Okay. That concludes this material for the homework problems that I wanted to review. If you have any questions, please don't hesitate to contact me. Thank you and have a great day.